In this lesson, we're going to find the sum and the product of roots of a quadratic equation by using the coefficients a, b, and c. And I want to remind you that the roots of a quadratic equation, if you picture a parabola crossing an x-axis on a graph, those are the roots, the x-intercepts. So you could have 1, you could have 2, you could have imaginary roots. So R1 and R2 represent the roots. So this is your quadratic equation in standard form, x squared plus bx plus c equals 0. If you divided everything by a, then you would end up with this form of that same equation. Now, if the solution or the roots of a quadratic equation are R1 and R2, then you could have x minus R1 times x minus R2 equals 0 be the one form of the equation. If we were to FOIL this, we'd end up with this equation down here. And if you simply set the coefficients of x equal to each other and set the constant equal to each other, you end up with the two formula for the sum and the product of the roots. So the sum of the roots, R1 plus R2, equals negative b over a. And the product of the roots, R1 times R2, equals c over a. Let's jump in and look at a few examples. What are the sum and product of the roots of the equation 6x squared minus 4x minus 12 equals 0? Well, the first thing I suggest is identify what are the coefficients. A equals 6, b equals negative 4, and c equals negative 12. So the sum of the roots is negative b over a. So we substitute in negative 4, and we end up with negative 4 over 6, which reduces to 2/3. So the sum of the roots equals 2/3. The product of the roots, R1 times R2, equals c over a. And c is negative 12 and a is 6. And negative 12 over 6 is negative 2. In the equation x squared minus 7x plus 2 equals 0, the sum of the roots exceeds the product of the roots by, these are your choices. So basically we need to find the sum and the product and subtract them to find how much the sum exceeds the product by. So a, b, and c are the coefficients. The sum, R1 plus R2 equals negative b over a. So we'll plug in negative 7 over 1, which is positive 7. The product, R1 times R2, equals c over a, 2 over 1, which reduces to 2. We'll subtract 7 minus 2 equals 5. Let's take a look at this one. If the sum of the roots, x squared plus 3x minus 5, is added to the product of its roots, the result is the following. So again, we need to identify the coefficients, plug in the sum of the roots, R1 plus R2 equals negative b over a. That evaluates to negative 3. The product of the roots, R1 times R2, is c over a, which is negative 5 over 1, which reduces to negative 5. Since we are adding the sum and the product, well, negative 3 plus negative 5 is negative 8. The answer is 4. Here's one that's important to look at because we start off not in standard form. You need to rearrange the equation so it's in standard form. So we're to subtract 11x and then add 6. We end up with 3x squared minus 11x plus 6 equals 0. Therefore, we can correctly identify the coefficients. A equals 3, b equals 11, c equals negative 11, c equals 6. And the sum of the roots is 11/3, and the product of the roots is 2. And there's your lesson. Best of luck to you.